Okay, there's two ways to find the volume of a solid. One is to use the washer method, one is to use the shell method. This page shows using the washer method where you have a typical washer perpendicular to the axis of revolution, which is this line x equals -1. And since we're dealing with horizontal distances, we'd like these functions to be written for x in terms of y. We want to know what x is depending on what y is as we move from 0 up to 1 along the y-axis. So we've solved this first equation, y equals x squared for x. X equals the square root of y. We already have x equals y squared. So we want outer radius squared minus inner radius squared. The outer radius is the x coordinate at the right, which is the square root of y, minus the x coordinate at the left, which is always a -1. So there's a formula for the outer radius. And here's the outer radius squared right here, squaring a binomial. The inner radius is the distance from here to here. And the x coordinate of this point is y squared for every y between 0 and 1. And so the distance, or the inner radius, is y squared minus the outer radius squared. And so using the washer method, it's pi times the definite integral from 0 to 1. That one is this one right here. By the way, you had to go to the trouble to find the point of intersection of these two curves. There's the outer radius squared minus the inner radius squared. We get this 3.036. If you multiply these or square these binomials and combine similar terms, this is what you get. And on the third board, we'll see the antiderivative of that expression. Here is the shell method. So our typical shell is parallel to the axis of revolution. And we want, it looks like I moved this picture around a little bit. That's okay. So now we want this height of the shell to be in terms of x, y in terms of x. So there's the y coordinate in terms of x for each of these curves. And using the shell method, we want the average radius, which is the distance from the axis of revolution to the center of a shell. This is an x, this distance right here. That's the x coordinate in the center of the shell, minus the x coordinate at the left, which is always -1. So there is the average radius. The height of the shell is the y coordinate at the top, minus the y coordinate at the bottom in terms of x. So the square root of x minus x squared. There's the integral. There it is expanded using FOIL, I guess, and you get the same answers. And here you can pause the video and check your antiderivative in both cases. But when you do f of 1 minus f of 0, you get 29/30 multiplied by pi, 29 pi over 30. That's your exact answer right there. And 2 pi times g of 1 is still 29 pi over 30. There you go. Hope that helped. If you have any questions, post a comment.